Hello and good day everyone. In the last video I've shown you how to use the ALU provided for by Circuitverse. Now there's a problem with uh, using it, especially when you're building a calculator, because during a subtraction the output of the Circuitverse ALU will be in 2's complement form. You need to convert it back into its original form. But first you need to detect whether the last result is a negative result or not. So what we are going to create here is a negative sensor, which will output a value of 1 if the result of the last subtraction is negative. So remember that, for example, in this case, we are going to subtract 10 minus 2. So our control will be 110. So 10, uh, in this case, we will have 10 minus 2, the result is 8. Now, if we will reverse the inputs, we will have 2 and 10. The result is 1000. Why is this? Because this is the 2's complement of 8. Remember, if you convert this to 1's complement, this will be 0, 1, 1, 1, 1. You add the 1 and pass on all the carries, it will be 1, 1, 0. So in other words, this is negative 8. So we need to find out whether the last result is negative or not. In order to do that, we have to check if the control is 110, because a negative output can only happen if the input to the control is 110, because remember that corresponds to 110 corresponds to subtraction, and a negative result only can happen during subtraction. It cannot happen during addition. So what we will do is to find out whether this is 110 first. But our problem is we do not have access to the individual bits. So like in the first video, we are going to delete this and we are going to split this into 3 bits. So we are going to go to the miscellaneous and then use the splitter and specify 3 bits and uh, press escape. So now uh, uh, we now have the splitter. Okay. Now we should know the we should know subtraction, because subtraction is 110. To be able to distinguish that, we can use an AND gate with 3 inputs. Okay, with 3 inputs. So the first bit should be a 0. So since it's a 0, it should be complemented. Okay. So we can use an output in this case to find out if the result is negative or not. This will be our negative sensor. All right. Now is this already enough? No, it's not. It only identifies that the last operation is a subtraction. However, it does not tell us that this is, I'm sorry, let me do that again. I didn't like the way it was placed. But it didn't tell us that the actual result is negative. How do we know that the actual result is negative? We will use another ALU. Okay, remember that Circuitverse ALU can compare both A and B. So to do that, let us put an ALU which is also connected to A and B, and we'll compare whether A is lesser than B. How do we know that? because it will compare if A is lesser than B if the control input is 1, 1, 1. Okay, so we will set the control input of this ALU to 1, 1, 1. How do we do that? We'll set all its inputs to 1, 1, 1. And actually in the input we have a constant of 1. Okay, this will be 1. But that's not enough because this will have to be 3 bits. Okay, so this is like connecting to the control of 1, 1, 1. Okay, so if the result is negative, the output, which is in the least significant bit, will be in the answer of the second ALU. So we need access to that, to that least significant bit, by which we need another splitter. We need another splitter. Okay, so this is the splitter we need, and this is the indicator that the result is negative or not is in this bit. Okay, so we can have access to this, but we have to AND this with the result, or we can just AND this with this bit. So we increase the input size of this. Okay, so that we can AND together this and this, and we'll connect this. Okay, okay, so this is now set to compare, okay, A and B. And okay, what happened to our, no, why didn't we have this? There's an error here. Is this a 4-bit? No, this is a 4-bit ALU. Okay, now we have the correct one. Okay, they follow. So let's find out. uh, uh, we didn't have an input, so first we need an input here to indicate. Okay, and then this will be the second one. We'll put it upwards because we are going to connect it here. This is an input. No, this is not an input. We'll connect this upwards because we are going to connect it here. Sorry, it should be in here like this. We'll cut this. We'll indicate another one. Point this upwards. Okay, and we'll point it here. Delete this. This one will connect here, and this one will connect here. Now we'll have an AND. Now let's do a negative, an addition. So take note that this is 1 to 2, 4. This is 6, and this is 1. This is a 2, 1, 1, 2, 4, 8. So this is a 14. So this is this is negative. Okay, but if you set this to 1, this is not negative because it's an addition. Now let's do subtraction again, and then let's make this higher. So this is not negative because A is bigger than B. But when B becomes bigger than A, this now becomes negative. So we are able to determine whether the result of the last addition, or rather subtraction, of the ALU is negative or not. This will be useful because you can use this to convert the actual result of this back into its original form from 2's complement. Remember, we can add, or we can change a number into 2's complement back again by using OR gates first to convert into 1's complement, and by using another ALU to add an extra 1 to the result. That will be your problem in your actual project. In this video, what is important is we are able to build a sensor that will determine first if the function to be done is subtraction, and find out if the actual result is negative. Hope to see you in our future videos, and I'll be glad to discuss the project with you in class. Thanks for watching, and bye for now.